In this ShowMe, we're going to solve this system of linear equations in two variables using the substitution method. A problem that shows up like this is ideally suited for the method because one variable is already expressed using a formula involving the other. I have a formula for y right here. It makes perfect sense then to take this formula and substitute it for y, which is exactly what we're going to do. So our first step is to take negative 3x plus 2x minus 10 equals negative 13. The beauty of this is, of course, that we've created an equation with only one variable now, which we already know how to solve. First, combine like terms. Negative 3x plus 2x gives us negative x. We still have a negative 10. We still have negative 13. Add 10 to both sides to clear the negative 10. We have negative 3. Now take the opposite of both sides, and we have x equals 3. Once we have this, it's very easy to figure out what y is. We already had a formula for it. Y is equal to 2x minus 10. But we can put 3 in for x now. So we have 2 times 3 minus 10. 2 times 3 is 6, and 6 minus 10 is negative 4. So we propose the solution, 3, negative 4, and we need to confirm that. Well, there's no need to put it back into the first equation, because that's where we got our final solution. We put 3 in and got negative 4. We know it's going to work in that equation. We should try our solution in the other equation and see if it works there. Well, we have negative 3 times 3 plus negative 4. Negative 3 times 3 is negative 9. And negative 9 plus negative 4 is negative 13. And that is indeed what we wanted it to be. So we have confirmed that 3, negative 4 is our solution. Note that you want to use the substitution method under certain conditions. And one of the best conditions, again, is that one of the variables has already been isolated, so that the substitution is very easy to find. You may still choose to use the substitution method if you get two equations in standard form, if any one of the variables happens to have a coefficient of 1. When that happens, it's really easy to make an addition or subtraction to each side and create a formula that you could then use for substitution. In a previous Show Me about the graphing method, we talked about the other kinds of systems of equations. This one's called a consistent system because we got a nice, neat solution. In the case of an inconsistent system, you're dealing with two parallel lines. There will be no intersection. When that happens and you try to use the substitution method, at some point you will get a statement that cannot ever be true. Something like 0 equals 4. Something like that. There's no number in the world you could put into the equation that would make that true. When that happens, you should stop. And unless you've made an error somewhere, you've got two parallel lines and you're not going to find a solution. The other possibility is that the lines are the same line, that they are dependent. That may not be obvious when you first start working. But if you end up with an equation that obviously can never be false, no number in the world can make the statement I just wrote on the pad false. Therefore, you have a dependent system. You're going to have infinitely many solutions because the two lines represented are in fact the same line. So be aware of that possibility. There are three things that can happen every time you're solving one of these equations. Or more appropriately, one of these systems of equations.